Well, hello. Today we're going to be starting chapter 7, the skeletal system. And as we look at this, we will discover that it is made up of bones. Right? So the skeletal system is made up of bones that work together. And remember that each individual bone, no matter how small it is an organ on its own because it has multiple types of tissue in it. It has not only bone, or what scientifically we call osseous tissue, it's got cartilage, it's got dense connective tissue, it's got blood and nervous tissue in it. So since it has more than one type of tissue, therefore it is classified as an organ. Um, and as it says, they are alive and multifunctional. They're going to have a lot of different things that they do, and one of them is mineral storage. Remember, I'm hoping that all of you understand that calcium is one of the big minerals we're looking at with this. We'll look at calcium phosphate, but just remember calcium is a big deal with bones. I think that most people know that, but a lot of times people forget that when they come into this class, just simply because you kind of overthink things. But remember, calcium is the key to bone health, but we're going to see calcium is the key to a lot of different things. But this is also where we are going to find this really amazing stuff called red bone marrow. This is where your hemopoietic stem cells are located, which again is just a fancy way of saying the stem cells that will make all the different types of blood cells are found in bone, in red bone marrow. They are going to be really important in movement. It will work together with skeletal muscles. That's why it's called skeletal muscles, to attach and cause movement. And then they'll also provide support and protection for soft tissues. For instance, your skull, the cranial cavity inside your skull is protecting your brain. It makes a very um, uh, sturdy helmet to protect you. Now, the skeletal system is divided into two divisions. You have axial, which is the skull, the head and neck, and the vertebrae, and the little sacrum here at the bottom. Um, and then the appendicular, oh, by the way, axial is also going to have the rib cage. The appendicular is going to be the arms and the legs, and what we're going to look at that we'll call the girdles that hold them on, the shoulder and pelvic girdles. But there's two divisions: axial, skull, vertebral column, sacrum, and the rib cage, and then the appendicular, the bones that make up the arms and the legs, and the structures that hold them on. Now, bones are very different from one bone to the other. They vary greatly in size and shape. Some bones are very small. The three bones inside your ear, the ossicles we call, all three of them can fit on the surface of a penny. Then you have a bone like the femur, the thigh bone, which is the largest and strongest bone in the body. So they vary greatly in these two things. And this is what we're going to look at, the shape of them here in just a minute and how we divide them up. But bones will have similar internal structure. They'll have similar development and function. But the size and shape, particular shape, is where we're going to divide them up. We're going to look at bones in 5 categories, classifications by shape. Now, there's only 4 listed here because this one, sesamoid bones, in our book is going to be listed under short bones, but we want to look at this one as it is separate on its own. That's a bad arrow there. So anyway, um, so the first are long bones. Long bones are what we're going to study for most of this chapter. We're going to look at the inner working of long bones. Long bones are not just long, because there are some misconceptions about that, but they are going to be tapered. They're going to be long like a tube. They're going to have a narrow hardened middle shaft with expanded ends. And we're going to see that you might have one like the femur, which again, I hate my little drawing thing here, which is, can be considered a very long bone. And if I put another, there's a long bone inside the hand. If I put one of those right next to it, it's going to be fairly short. And so understand that long bones are just a general idea of what we're looking at. Short bones are going to be cube-like. That's kind of the key. They're going to be like little pebbles. They're going to be roughly the same width as they are as the same length. And the short bones we're going to look at are going to be carpals. Those are going to be the classic example of the short bones. And the classic example of the long bone I will use is going to be the femur in general. I'm going to come back to sesamoid bones in a minute. Flat bones, I'm hoping everybody understands, and it says they're plate-like here, which just is a way of saying they're flat. They didn't want to say flat bones are flat because it sounds a little too basic, but that's the idea. Flat bones are flat. I would use cranial bones as the example of a flat bone, but there are many different types, like all of them. But the cranial bones are my classic example of flat bones. Irregular bones, now again, when I was a student, I would thought every bone was an irregular bone. I mean, they have weird shapes and whatever, but true irregular bones are very weird. Weird even among the weirdness of all the other bones. The classic example for an irregular bone would be a vertebrae. Facial bones could also be one, but the classic example I would give would be a vertebrae. And then finally, I come back to this one, the sesamoid bone. Now, this is kind of weird. Sesamoid is supposed to mean sesame seed like, which is how a lot of them are described or would look, would be a good description of a lot of them. Because what a sesamoid bone is basically a calcium deposit inside a tendon. If you ever see pictures, x-rays, I should say, of hands or feet, a lot of times you'll see little calcium deposits on these tendons, and they're called sesamoid bones. Now, we all share one sesamoid bone, and we call it the patella, which is the fancy way of saying kneecap. And so when we look at these, again, long bones, the femur, the long bone is going to have a hardened middle shaft with expanded ends. Again, the femur is the classic example. Short bones, we're going to say carpals, the little bones in the wrist. They are basically cube-like. Flat bones, again, are going to be flat. We say that they are cranial bones, would be the ones I would use. Irregular bones are very odd and just have lots of nooks and crannies and holes and processes coming off of them. They're very irregular. And again, the classic example are vertebrae. And then finally, the sesamoid bone, the classic example is the patella. And this little picture kind of shows the different bones that we would talk about. Although the one thing that I would say here that is different is the irregular bone, which it uses the tarsal, one of these bones in the ankle. I would use a carpal, and it would be pretty obvious what I would use, but that's basically what those little short bones were. So anyway, this is the beginning. This is the idea of how bones are organized and how they're classified. And then we will start the journey of looking at really what they are. Take care and have a great day.